Hi, I'm Lavanya. We are Group 6 and the topic is drying. Our team members are Madhvi, Madhur, Mayur, Mandar, Mayank, Netik Singhal, Netik Verma, Neelat Majam and Nikita. So what is drying? Drying means removing small amounts of water or other liquids from solid materials to reduce their moisture to a low and acceptable level. In simple terms, it is the process of evaporating moisture from a wet solid using heat. So as shown in this flow diagram, we can see a wet solid is first applied with heat, which causes moisture to evaporate. Then the vapor is removed and we get the dried solid as the final product. The figures here show the main stages of drying: surface moisture evaporation, constant wait period, and equilibrium moisture content, which we'll discuss more detail in later. So drying is a very important step in many industrial processes. It helps in preventing the microbial growth and spoilage, especially in food and pharmaceutical products. It also reduces the weight of the product since less moisture means a lighter product, which lowers the transportation cost. Dry materials are also stable and chemically and physically stable, and drying also prevents unwanted reactions like corrosion and oxidation. In industries like coal, biomass, and ceramics, drying improves combustion efficiency and reactivity by reducing moisture content.
Now, as we are done with what is drying and what is the importance of drying, let's move on to the next topic that is classification of dryers. Dryers are classified into two parts that are adiabatic or direct dryers. What are they? Dryers in which there is direct exposure of the solid to the hot gases. While the second part is non-adiabatic or indirect dryers. What are they? Heat transfer from an external medium without direct gas contact. While there are some other classifications as well, they are continuous dryers and the batch-wise dryers. We will not tap into them, but we have explained them in a quite detailed format down here. So let's move on to the next thing, that is solid handling in dryers, especially in adiabatic dryers. For that, we have four types of solid handling that are open circulating drying, in which gas is blown across the surface of a bed or a slab or of solid or across one of the faces of the continuous sheet or a film. The second is spray drying. It is explained here, while the third is through circulation drying, and the fourth is fluidized bed drying. All the four points are well explained in the given slide. Moving on to the next slide, that is solid handling in dryers in non-adiabatic dryers, in which in the first here also we have four types. The first one says that solids are separate over a stationary or slowly moving horizontal surface and cooked until dry. The surface may be heated electrically or by a heat transfer fluid such as steam or hot water. The second one goes into the solid slide by gravity over an heated inclined surface or carried upward with surface of time and then slide to a new location. And the third says that solid are moved over a heated surface, usually cylindrical, by an aerator or a screw or a paddle conveyor. The fourth one also says that a stream of hot gases is passed through a bed of finely divided solid, causing the particles to become suspended and vigorously mixed, resulting in rapid drying. So this was solid handling in dryers in both adiabatic and non-adiabatic dryers.
So we are done with importance of drying. Now we move on to types of dryers. First is the tray dryer, which uses hot air circulation over trays for drying. Another one is fluidized bed dryer, also called FBD in short, in which suspended particles in hot air are used for efficient drying. Next is the rotary dryer that employs a rotating drum for continuous drying and stirring. The spray dryer atomizes liquid feed into fine droplets for instant drying. The next type of dryers are tunnel dryer, which uses continuous drying with countercurrent airflow so as to efficient and increase the process of drying. Vacuum dryer uses low temperature drying under reduced pressure for creating a vacuum system in which drying can be more efficient. Drum dryer, which has rapid drying of liquids on heating rotating drums. The freeze dryer, sublimation based drying for heat sensitive materials are used. Now we move on to heat transfer and drying. Heat transfer can majorly be done via three paths. Conduction, in which heat is transferred by direct contact between a hot surface and a wet material. Examples are drum dryer, tray dryer, rotating vacuum dryer. Another mode is convection, in which heat is transferred from a hot air or flue gas to the wet solid by convection. Examples: spray dryer, fluidized bed dryer, tunnel drying. Third is the radiation, in which heat is supplied simply as electromagnetic waves, which may be infrared or sunlight, which are absorbed by the solid surface. Example: infrared rays or solar dryer.
Drying might sound like a simple process, just removing moisture, but it's actually one of the most important industrial operations we encounter every single day. Let's start with the chemical industry. Here, drying helps in making polymers and resins by removing leftover solvents or water after reaction. It's also used when producing salts and crystal to keep them pure and free flowing during storage. Even catalysts, the material that speeds up reaction, need drying before they can be activated or used. Moving to food industry, drying is everywhere in our kitchen. From dried fruits and milk powder to instant coffee and soup mixes, all depend on drying. It helps preserve food by reducing moisture, which stop microbial growth and reduces weight for transport, and also extends shelf life. In the pharmaceutical industry, drying ensures the stability and quality of medicine. Tablets and capsule requires the right moisture content for proper compression and flow. Some drying techniques are used to maintain sterilized condition, also drug protection. The agriculture and biomass sector also relies heavily on drying. Grains and seeds are dried to prevent fungal spoilage, and biomass or biofuels are dried to make them burn more efficiently. Finally, in the textile and paper industry, drying gives us smooth fabric and printable paper. After dyeing or washing, fabrics are dried to improve texture and color. Similarly, the wet paper bulb is dried to achieve the right strength and finish. So, whether it's the clothes we wear, the food we eat, or the medicine we take, drying plays a quite but crucial role in our everyday lives. Thank you.